Good morning, scholars. Let's take a look at our science review for 2014. Let's start with astronomy like we did this year. Recall back that we looked at a guy by the name of Aristotle. And Aristotle, we've come up with his name several times throughout the year, and he's got a whole bunch of ideas. Most of them tend to be incorrect, but he's got us thinking about the world. He got us thinking about uh, things that we normally in everyday life perhaps didn't reflect on. So Aristotle was really important because he was a real supporter of the geocentric theory, the idea that the Earth was the center of our universe. Now, at that point, they thought that their solar system was the universe because they couldn't see any further than that. And he figured for sure that the geocentric theory was the right theory because of several reasons. Number one, he couldn't feel any movement. So if the Earth was actually spinning, then there would be some movement. In number two, and these are not in any order, but just happen to be 3 points. Two was the gods. Their culture was highly dependent on the idea of gods, and gods were really important. And when something's important, you place it in the center. And therefore, if gods visited the earth, then they would be in the center of the universe. The third idea was the movement of the stars. If they watched the stars at night and they would see that they would appear to rotate around the North Star or Polaris. And so it was based on these ideas that even though someone else has already mentioned the idea that, hey, maybe the sun is the center of the solar system, Aristotle stuck with these ideas. It was only until relatively recently that a guy by the name of Copernicus started thinking about, hey, hold it. This doesn't make sense because the old geocentric theory had to come up with ideas because Mars seemed to be traveling this way and then back way, that way. Do you remember what that was called? That was called the epicycles. Epicycles. And these epicycles were the apparent backwards motion, and that was called retrograde motion. And epicycles didn't really exist, but it was the way the Greeks used to try to explain why it appeared that Mars was going backwards. Well, the guy by the name of Copernicus actually decided to do a little bit of an experiment. Now, he figured out that if the sun was the center, by placing the sun in the center, and the Earth traveled around this way, and Mars was on the outside, at one point Earth would actually catch up to Mars, and it would look like from the backdrop of the stars that Mars was going backwards. So epicycles was an optical illusion and a way of explaining this backward motion. All right, so then after that, we looked at the reasons for day and night, and of course, the reasons for day and night, we looked at a grade 9 appropriate answer. The reasons for day and night is that during the day, the Earth is because of the Earth's rotation. Now, we use the idea of rotation because it was rotating around itself. When Earth is moving around the sun, we call that revolution. So because of the Earth's rotation, we have day and night. When we face the sun, we have daylight, and we face away from the sun, we have nighttime. It takes 24 hours to make one complete revolution. All right, after all of that, we looked at reasons for the seasons. And one of the reasons we looked at reasons for the seasons, and the reason we have seasons is we have the sun as the center, and we have Earth, and it's the 23.5-degree tilt of the Earth. Now, during winter, the northern hemisphere has more direct, more concentrated sun rays. We also have longer daylight hours. So there's two reasons. During the winter months, during the winter months, the northern hemisphere has less direct light rays and shorter daylight hours. And we proved that in the class using those strings. The times when the daylight and nighttime are equal is called the equinox. We have two equinoxes. We have a March equinox, and we have a September equinox. The the short, I've got this mixed around. This should be March, and that should be September because we know that this is winter, so this is December. Okay, so that's March. This would be September, fall equinox. This here we have in June, and that's coming up. June 21st will be where we have the longest daylight hours. And moving around, what is time? So we talked about time as being a location. So if those are June, then we can count through. So then we have June, July, August, September, October, November, December, January, February. So months is our revolution around the sun divided into 12. All right, after that we looked at phases of the moon, and phases of the moon we looked at what causes the shapes. Remember, the shape of the moon, half the moon is lit constantly. So if the Earth is here and the moon is here, if the sun is coming from this direction, then half the moon would be lit and the other half would be dark. That means that from Earth we would only see this portion of light. And so we would end up seeing a half moon. So here we would end up seeing a no moon, or it's called a new moon. And a full moon would be over here, and this would be the first quarter, and this would be the third quarter, and here would be crescents on either side. And remember what this one was called? A gibbous. And this would also be a gibbous. Now these, when here the moon was shrinking, and that was the waning. And on this side here, the moon appeared to be growing, and that was called waxing. Now, from that, we looked at other ideas of constellations that were groups of stars that appeared to travel together. We looked at distances in space, and we looked at the distance from the sun to the Earth, and we knew that that was 150 million kilometers, and that is called 1 astronomical unit. And we use that to measure distances within our solar system. Distances that are for beyond our solar system, distances into the universe, we use something called a light year. And a light year is the distance that light travels in 1 year. So even though it has the term year in it, it's still a distance unit. We looked at a variety of different other terms that you will have to come into the exam ready with, including what is a star, what is a sun, what is an asteroid, a meteor, meteorite, moon, satellite, comets. That pretty much completed our unit. Thank you.